Hello and welcome to the Practical Linux Malware Development course. My name is Nemuel and I shall be your instructor throughout the course. A bit about myself. As said earlier, my name is Nemuel Wenaina. I am a security researcher and software engineer, and if you'd like to get in touch, view my work, or learn more about myself, you can check out all these links that are listed here. I'm available on LinkedIn and Twitter. You can check out some of my articles on Medium, as well as some of my projects on GitHub. Now, over the past couple years, there has been a tremendous spike in malware targeting Linux platforms, and the major reason for that is that companies are increasingly migrating to the cloud. Now, when you get to the cloud, it is Linux that dominates, with about 90% of the cloud running on Linux. There's a few reasons for that, and we have some of them right here. Linux is open source, it has better security, and it allows for extensive customization. Now, attackers are after data, and so, as you might have already guessed, they are going to adjust their tactics and techniques to suit Linux platforms, hence the increase in malware targeting Linux platforms. So what are we going to be developing? This is a practical course, and therefore we are going to actually create our own malware from scratch. We are going to be developing a remote access Trojan using the Go programming language, and later on create a command and control server for the same using Python. Now, our malware is going to have all these capabilities to take a screenshot, file upload, file download, shell command execution, and we shall finally take a look at persistence. Now, a disclaimer here, I will not be responsible for any irresponsible use of the knowledge and skills gained in this course. I urge us all to work towards making the internet a safer place. In the next video, I will do a demonstration of the final project that you and I need to have by the end of the course. See you there. Hello and welcome back. As you can see, with me here are two terminal windows open, and on one I'm going to run the command and control server, and on the other window I'm going to execute the malware. So for the command and control server, the command is python 3 space server.py, and as you can see, it's listening for incoming connections, and on the other window I'm going to execute the malware, so /Trojan, which is the name that I've given it. And as you can see, as soon as I hit enter, we receive a connection on our command and control server. Now with this prompt right here, we can type in any command and receive the results. So for example, who am I? And we get back the username of the currently logged on user. pwd gives us the current working directory on the target machine. ifconfig gives us the network information on the target machine. So all of this entail shell command execution, and the other feature of our malware is file download. Now what that means is that we can transfer files from our target machine onto our command and control server. So we can do a file listing, and as you can see, we only have our malware. So I'm going to navigate around the file system using the cd command. So cd ... and I'm going to go to the documents directory. And if we do a pwd again, we can see that we are actually in the documents directory. Let me do a file listing, and guess what? We get a secret.pdf file. So the next thing we are going to do is download this file onto our command and control server for viewing, and the syntax for that is download space followed by the name of the file, in this case secret.pdf. Hit enter, and as you can see, we get a notification here, file saved successfully. Let's open our command and control server location, and as you can see, we have a new file right here called secret.pdf. Let's open it, and as you can see, we are able to view its contents. The other feature we are going to try out is file upload. Now this is the opposite of file download, and it essentially means transferring a file from our command and control server back to the target machine. The syntax for that is similar to the one for downloading a file, so it is upload space followed by the file name. And before I do that, I'm going to just do a listing of the files that we have right here, and so the one that we are going to do for this is the config file. So I'm going to simply do upload space config, hit enter, and we get a notification that the file has been uploaded successfully. To confirm that, we can simply do a listing, and as you can see, we have that file on the other side, which is our target machine. The other feature that we are going to see is taking a screenshot. Now the command for that is simply screenshot, and after typing that, I'm going to hit enter, and we get a notification that the screenshot has been saved successfully. Again, we check where we have our command and control server. And after opening it, we are able to see a screenshot of our target machine, which in this case is just our desktop. I'm going to close that. And the final feature is persistence. Now the command for that is persist and hit enter, and we get a notification that the persistence has been established successfully. What this means is that whenever we reboot whenever the target reboots their machine, we will still be able to get a shell on their machine because our malware will automatically start. Finally, if we want to close our connection to the target machine, we can use either Q or the quit command, and the connection will be closed. Our malware will also terminate. So we have our malware running right here. I'm going to do quit, hit enter, and as you can see, we get a message here, closing connection, and our malware stops executing. That is it, guys, and this is what we are going to be creating throughout the course. See you in the next video. Hello and welcome back. In this lecture, we are going to go through the environment setup that you will need in order to successfully follow along the course. So what are we going to need? One is a Linux-based operating system, e.g. Ubuntu, Kali Linux or Parrot. We'll also need a code editor, which is where we are going to be writing our code, for example, Visual Studio Code. We will also need the Go compiler, since we are going to be using the Go programming language, and also a Python interpreter, since we will also use Python. So where do we get all of these? So with me here open in my browser is Ubuntu's website, where you can go and get the Ubuntu operating system. And just in case you do not have a Linux operating system on your bare metal, you can simply get a virtualization software, for example VirtualBox, download it and install it. Then you can get a Linux distribution and run it on top of the virtualization software. Next is a code editor. I'm personally going to be using Visual Studio Code, and this is the website for the same, code.visualstudio.com. and as you can see here, you have a download button as well as here. Next is the Go compiler. You simply head over to this URL, https://go.dev/doc/install, and here you'll find the installation instructions for the Go compiler on all platforms. So for our case, we are working with Linux, and going to the Linux tab, you can find all these instructions right here in order to install Go. Finally, we need a Python interpreter, and here is Python's website, www.python.org/downloads, and you can simply download the latest version right here. That is it for this lecture, guys, and I will see you in the next one. Hello and welcome back. In this section, we are going to be developing the remote access Trojan, and for the first lecture, we are going to set up the project and write down a plan. So I'm going to open my terminal right here, navigate to the desktop, which is where I'm going to be working out of, and create a directory that I'm going to call malware, which will contain our malware's source code, and I'm going to open it in my code editor, which is Visual Studio Code. Now, as you can see, the command for that is code space followed by the name of the directory, in this case malware. Once that is done, I'm going to create a file in our directory. I'm going to call it plan. It is going to contain a plan for developing our malware. So the first thing you are going to do in our malware is to connect back to the command and control server, in short C2 server. And once we have done that, we are going to start to receive incoming commands from the C2 server. And with the command, we'll be able to perform the desired action. Now these actions, one of them is to terminate the connection, and the commands for that will be either Q or quit. So this means terminate the connection. The other command we might expect is the cd command with an optional target directory, which means change directory to the target directory. The other one, we have file upload, as I had mentioned in the first section, file download, screenshot. We also have persistence, and we have shell command execution. So we'll be able to perform all of this based on the command that we have received. Shell command execution. Okay, now that out of the way, I'm going to create the file that will contain our code, and I'm going to call it main.go. Note that the .go extension is because we are working in the Go programming language. Now for a start, I'm going to create a simple hello world program that will help those of you that are new to the language to understand the basic structure of a Go program. Now, the first line in every Go file that you will create has to be a package declaration. So every file that you create in the Go programming language has to be part of some package, and in our case, our program will be part of the main package. Now, the reason for that is that we are going to be actually building and executing our file. Once we have done the package declaration, the next thing we need to do is to import any packages that we are going to be using in our code. So this is our Hello World program, and that means that we are going to be printing out the text Hello World on the terminal. So I'm going to import a package for standard input output, and that is FMT in Go. And once that is done, we are going to create our main function. Now, if you have worked with other languages like C and C++, you understand that execution starts from the main function. The same applies for Go, and so I'm going to create the main function right here, func main. The func keyword is for the creating functions, and inside of here we are going to use the print line method of the FMT package, which simply prints out a line of text, and in here we are going to type in our string. And that is it for our first program. Now, to execute it, I'm going to open the terminal, and once that is done, we have a number of options to run our code. So first, we can build our program and then execute the binary. So as you can see, we get another file here, which is our binary, and then we can execute that and we get back our output, or we can directly run our code. So the command for that is go run followed by the name of the file, that is main.go, hit enter, and we still get the output. Now, in the next video, we are going to get started with the first step of our plan, which is to connect back to the C2 server. See you there.